Somewhere off the coast of Greenland, a patch of ocean is doing something it should not be doing. While the entire planet heats up, this one stretch of water is getting colder, not slightly colder, dramatically colder, in a way that has climate scientists staring at their monitors in disbelief. They call it the Cold Blob, and it might be the single scariest anomaly in the North Atlantic right now. Here is why this matters to every single person watching this video, no matter where you live. That cold patch is not random. It is a direct signal that one of the most important current systems on planet Earth, the Atlantic Meridional Overturning Circulation, known as the AMOC, is losing power. And if you have never heard of the AMOC before, you are about to understand why oceanographers consider it one of the most important machines on the entire planet. Think of the AMOC as Earth's central heating and cooling system. It is a massive conveyor belt of ocean water that carries warm water from the tropics up toward Europe and the Arctic, then sends cold, dense water back down deep beneath the surface toward the equator. This single current is the reason why places like the United Kingdom and Western Europe enjoy mild winters, despite sitting at the same latitude as freezing regions of Canada. Without it, the climate map of the world would look completely different. To really appreciate how much weight this one current carries, picture London and Labrador in Canada sitting at almost the exact same latitude. One has mild, rainy winters where snow is a rare event. The other regularly buries itself under feet of snow for months at a time. The difference between those two places is not luck. It is the AMOC, quietly moving heat northward across the Atlantic Ocean, year after year, century after century, without most people ever giving it a second thought. That is exactly what makes this story so important right now. A system this large, this powerful, and this consistent for thousands of years is not supposed to show sudden signs of instability. Ocean currents of this scale typically change on timescales of centuries, not years. When researchers start detecting measurable shifts within a single human lifetime, that is the kind of anomaly that forces an entire scientific field to sit up and take notice. Now scientists are watching that engine sputter. Data pulled from deep ocean buoys scattered across the Atlantic shows current speeds slowing down at multiple points along the system. This is not a single instrument malfunctioning or a one-year fluke. Multiple independent measurements, taken across different parts of the ocean, are pointing to the same conclusion. The AMOC is weakening, and it has been weakening for a while. The Cold Blob is the most visible fingerprint of this slowdown. As the AMOC loses strength, it stops efficiently pulling heat northward. Meanwhile, cold meltwater pouring off the Greenland ice sheet has nowhere productive to go. So instead of being swept into circulation and distributed, it pools right there in the North Atlantic. The result is a patch of ocean that stubbornly refuses to warm up, while record heat bakes almost everywhere else on the map. This is where the story stops being an abstract climate curiosity and becomes something that could reshape weather patterns you actually feel. Researchers studying the Cold Blob have linked it directly to disruptions in the jet stream, the fast-moving river of air high above our heads that steers storms and temperature swings across entire continents. When that jet stream gets knocked off its usual path, the consequences show up as extreme weather events in North America and Europe. We are talking about unexpected cold snaps, unusual storm tracks, and rainfall patterns that no longer match historical norms. Meteorologists describe the jet stream almost like a river bending around obstacles. A stable, strong AMOC key keeps that river flowing in a fairly predictable channel. But when a stubborn patch of cold water sits in the North Atlantic while everything around it warms, it creates a temperature contrast that can bend the jet stream into unusual loops and dips. Those loops are exactly what allow Arctic air to plunge unusually far south, or what allows storm systems to stall over one region for days instead of moving through normally. If that sounds familiar, it might be because you have already lived through some of these unusual patterns without realizing there was a deeper ocean story behind them. Sudden cold snaps hitting regions that rarely see them, storms that seem to sit in place and dump enormous amounts of rain, and winters that swing unpredictably between mild stretches and brutal cold fronts. Scientists studying the AMOC believe a weakening current is one of the contributing forces behind these erratic patterns, layered on top of the broader effects of a warming planet. If you are enjoying this deep dive into what is genuinely one of the more unsettling ocean stories of the year, go ahead and hit that like button right now. It helps this channel keep bringing you research-backed breakdowns like this one, and it takes less than a second of your time. Scientists are not entirely in agreement on what is driving this slowdown, and that disagreement itself is part of what makes this so fascinating. One camp, led by researchers like Lai-Fang Li at Penn State, argues that atmospheric forces are the primary trigger, meaning changes in wind patterns and air circulation are pushing the ocean into this unusual state. The other camp, represented by climate scientist Stefan Rahmstorf at the Potsdam Institute, points to the ocean itself as the root cause. His research team tracked heat loss from the ocean surface all the way back to 1955 and found a steady decline that lines up with a mechanical slowdown of the currents themselves, not just a temporary atmospheric quirk, Rahmstorf has been blunt about where he stands on this debate. He has stated plainly that even though some modeling approaches suggest the atmosphere could be behind the cold blob, the actual data tells a different story, one where the ocean itself is driving the change. When a scientist with decades of ocean current research says that, plainly, it tends to carry weight in the broader climate community. Here's the part that should really grab your attention. This is not just about one cold patch of water making headlines for a news cycle. Scientists studying long-term projections warn that if the AMOC continues on its current trajectory and eventually collapses entirely, it could function as a genuine climate tipping point. That means a single system failure could trigger a cascading chain reaction across global weather patterns. Some models suggest this kind of disruption could set in as early as 2040, which for a lot of people watching this video is well within your own lifetime. To put that in perspective, a full or partial AMOC collapse would not simply mean a slightly chillier Europe. It could mean colder winters slamming into some regions, while other parts of the world experience drier, more erratic conditions, all at the same time. Agricultural cycles that farmers have relied on for generations could shift. Fishing industries tied to specific water temperatures could be upended. Coastal storm patterns that insurance companies and emergency planners have modeled for decades could suddenly become unreliable. Think about how much of modern civilization is quietly built around the assumption that ocean and weather patterns will stay roughly the same as they have for the last 100 years. Shipping routes, crop planting calendars, city infrastructure designed for expected rainfall levels, even something as simple as when farmers decide to plant seeds in the spring. All of it rests on a foundation of relative climate stability. A major current system shifting gears does not just change the temperature outside your window. It quietly undermines the assumptions baked into entire economies. There is also a slower, more subtle danger buried in this story, and it has to do with how tipping points actually work. Unlike a gradual temperature increase that creeps up slowly and predictably, a tipping point behaves more like a light switch. The system can appear stable for a long stretch of time, absorbing stress and shifting only slightly, right up until it suddenly crosses a threshold and flips into a completely different state. Some researchers worry that by the time the AMOC shows dramatic, undeniable signs of collapse, it may already be too late to reverse course quickly. What makes this story stand out from a lot of climate coverage is how directly measurable it is. This is not a projection based purely on computer models running decades into the future. Real boys, sitting in the actual ocean, are recording real data right now, and that data keeps pointing in the same troubling direction. The cold blob is not a theory. It is sitting there on satellite imagery and temperature readings for anyone to see. It is also worth noting that this alarming ocean signal is showing up at the same time the rest of the planet's oceans are logging some of the hottest temperatures ever recorded. Marine heat waves have spread across a massive share of the global ocean this year, with hotspots emerging in the Mediterranean, the central North Atlantic, and the equatorial Pacific. Oceanographers monitoring these trends describe the ocean as being under sustained thermal stress, which makes the cold blob even stranger. It is a pocket of cold sitting inside a planet-wide heat surge, almost like a warning light flashing in the middle of an otherwise overheating system. Layer on top of that, the possibility of a strengthening El Niño pattern developing later this year, and you get a picture of an ocean system under pressure from multiple directions simultaneously. Satellites have already detected a massive pulse of warm water traveling across the Pacific towards South America, a signal scientists associate with the early stages of El Niño formation. When you combine a weakening AMOC in the Atlantic with a potentially powerful El Niño building in the Pacific, you are looking at two of the planet's most influential ocean systems, both showing signs of major disruption at the same time. None of this means the sky is falling tomorrow. Climate systems operate on timescales that stretch across decades, and there is still genuine scientific debate about exactly how fast these changes will unfold and exactly how severe the consequences will ultimately be. But the trend lines matter, and right now nearly every independent measurement of the AMOC is pointing in the same direction, and that direction is weaker, not stronger. For scientists who have spent entire careers studying ocean circulation, this is the kind of signal that shifts research priorities almost overnight. Monitoring programs that used to check in on AMOC strength periodically are now racing to deploy more instruments and gather more frequent readings. Nobody wants to be the research team that missed the early warning signs of a tipping point that reshaped global weather. For the rest of us, the takeaway is simpler but no less important. The ocean is not a silent, unchanging backdrop to daily life. It is an active, dynamic system that regulates the climate every single person on this planet depends on. When it sends out a signal this clear and this consistent, it deserves attention, not just from scientists and labs, but from anyone who wants to understand what the next few decades of weather and climate might actually look like. It is easy to scroll past a headline about a cold patch of ocean water and assume it has nothing to do with your own life. But the AMOC touches far more than most people realize. From the price of food, shaped by shifting growing seasons, to insurance costs, shaped by unpredictable storms, to the everyday weather forecasts that increasingly seem to defy historical expectations. A single ocean current, quietly weakening thousands of miles away, has a way of eventually showing up much closer to home than anyone expects. Before you go, if this kind of research-driven breakdown is something you want more of, make sure you are subscribed to this channel so you never miss the next deep dive. There's a lot more happening beneath the surface of our planet than most people realize, and we are going to keep tracking it, one story at a time. Thanks for watching, and we will see you in the next one.